Hello, for today's class, our CSCI 310, cybersecurity. And for today, we'll move on to a new topic that's related to the network security. And when we talk about the network security, there's like something we need to consider. Okay, of course, the architecture of and then all the components like involved. So when you think about it, of course, like there's some lots of example. If you heard about the Internet Security firewall or some like nowadays we have lots of like different type of connection and encryption methods like to enhance the network security. And for when we move on, so we will talk about like of course like knowing some like basic including the information flow. Okay, so what will be those like network security involved and then the possible like use case and communication security, all these. Okay, and then we will cover there some like what are the devices involved and then the access control and some topologies for the network. How can we secure the network? And then we will talk about with the segmentation of the network and then the intrusion detection. And there's some securing software defined network. And then last one, we will talk about the zero trust architecture. So this one is a pretty long topic. So for coming the rest of the class will cover this chapter. Okay, and right here when we move on, so for the information flow, we talk about the control system. So we try to control like all these like assets. So of the world type of the inherited information flow. So one example is the firewalls. Okay, so when we use it, so including how can we protect the like privacy or the Android cell phone in case like this. So the information flow problem, so is like saying, okay, so the information, so they're flowing from the phone to external parties. Okay, there are many like maybe some commercial apps. Okay, they use the advertising the libraries to monitor the clicks, fetch ad, display them. Especially Android platform, they are more like open to the developer. So sometimes if you have official applications and actually you can inject or like add some like banners and advertisement on it. Okay, so even third party, even the company itself, like the company, so they can do it in this way because they want to monitor like what's the popular click, or sometimes they will add the banner like the header footer. Okay, so when you playing, especially like when you're playing games, okay, so they will pop out, you have to watch like a short video like this. Okay, also like when they gathering your information, okay, so they can send those like advertisement like which can help like for the really tailored customer. So nowadays when they know you like click on, let's say if recently you're always looking for clothes, right? So they maybe keep like sending some maybe different platform like selling clothes or with discount. Okay. Or if you heard about it like for the phone, they will access to your a microphone. Okay, so many app maybe have like try to get a full access some like photos data, so they will um gather those information to better like tailor some ads to you. So this way actually if you look at the phone, they will make all the permission structure like in the Android system like really kind of complex. So that's why it caused an issue. And right now for iPhone App Store slightly better. Okay, and then nowadays actually if you observe, so if they access your microphone, they have a light on it, and then maybe the camera. So all this, if they need to access certain your hardware, so they will let you know. But of course, like in behind, if they monitor your click or your search, then it's really hard to tell. Okay, you may not know. Okay, so those are apps displayed with the privilege of the app. So maybe they use the JavaScript. So then they will execute those privilege. And if they grant a full access privilege, sometimes they can send your contact list there, your contact from your phone, and then also maybe the address or even other information stored on your phone, then to others. So this way is a serious problem. And when we analyze this like Android phone. So first we need to know Android is like based on Linux. Okay, so those apps that were executable in like bytecode format. So they will be like different type executables or DEX or like um one in the WVM. So all those apps will be event driven. So they were based on the event. Okay, the listening and those and they will use the system library to do many of their functions. And those like binder subsystem will control the inter-process communication. So it's how it works like. And when we need to analyze, so we can see there are two security levels. So they are untainted and tainted. So maybe some like no categories, okay, and then the untainted and the untainted, they will be like higher. So there's a two for them. And when we move on, when we need to checking the information flow, so all the objects they are tagged like this, right? So two of them. So we require the interpreter or binder arguments to handle all tags. And of course, they have a native library, so they trust their own and doing the communication. So they were communicating in externally. So we have a training sync. So this one, and when they have an untrusted app invoke, okay, in those, so they will have a tag. Okay, so those data is recorded, and those like tag will be assigned to some external variables, or those library will return the values. That's how it looks like. And they will kind of like based on the knowledge what they have, like which what the native code does, then they will assign to them. And also those like files have a single tag, so they will update when the files is written. So it's the way. And of course, you know the data, so they will those we have the database like query to retrieve the data. So the tag, so we can determine by the database like query responder. So it's the way like sending the flow. And the information from the phone sensor, so maybe kind of like sensitive. So if say we attend, so it will be like job. So it will determine like this from the characteristic of the information. This is a previous experience checking. Okay, so they will select some like 30 popular apps out of set of like 358. So they sometimes they require permission to access internet, phone location, camera, microphone. So they can also access the phone information, all this. And you will see able to find like most of they have some like they require the like the network connection, and then they send the phone identification info or some like the device identifier to third party. Okay, and they didn't tell the someone, they didn't tell the user, or the location information they pops out, they say you have to share the location. Okay, and all these will be the information, okay, they're sending to the server. And sometimes they don't ask you to let you know. Of course, nowadays I think especially because I'm using iPhone, so you can tell like most of the app they will, or like the app, if they require to gather certain information, including your maybe photo, location, or like access your device, like let's say Bluetooth. Okay, so you have to allow the permission, like giving the privilege to let them to access it. Okay, so also you can control. So why not? There are even the cell phone manufacturer, they are trying to like enhance the security. Okay, so which can help. And there's some like sending location to third party or some more information. So we don't have to go. And quickly we go through the flows of the data. So always like we have the device and then gather the information, okay, data, okay, no matter your privacy or sensitive data from the device. Okay, so then they will send it to the server. Okay, there are manufacturers, sometimes they want to make their purpose not really like selling your data, but sometimes they want to give you the tailor advertisement. Okay, actually for not only Google, sometimes like Meta, Instagram, Facebook. Okay, so actually when you post something, and then if you want to like specific area or country of the user like able to see your ad, then you can let specific location. So here's the reason why they need to gather your location information or some other information, or they can get your like age group, okay, the range, the like maybe for the teenager or middle age or elderly, so it depends on your product. Okay, so you can more specific on like promoting those ad to the user. So here's the reason why they need to gather your information. And when we move on, because you remember we talked about the firewall. Okay, so firewall actually is a host that mediates the access to a network. Okay, so it can allow you, or sometimes we can disallow the access, like maybe two-way. So based on the configuration and type of access, and we sometimes have a term like inbound, outbound, so going out, going in, and then when we set the port, okay, so all this. And one example, the block configure room. So this one will be like have a configure. So we try to connect to the botnet, so it can use the system for many purposes. Okay, so they will spread through all those like vulnerability in the particular network surface. Okay, so for the firewall, will analyze the package. Okay, so package, they are using the surface remotely and looking for like configure and it's the version. So if you find then the package, so will be discarded. Okay, maybe other actions may be taken like this. And code configure, it also generates a list of the host name. So they try to like contact the botnet at those hosts. Okay, so as I said, for domain also, maybe the firewall can also like block those outbound top the outbound traffic to those hosts. Okay, so here's the idea of firewall. And when you look at your, maybe if you look at your router, okay, maybe if your device, sometimes we do have firewall, and also maybe there's some companies selling their maybe hardware, like physically there's a called firewall or software. So we have different type of firewall. So the one is like using, we have the called a package firewall. Okay, so for package, it's work on the physical and then data link and network layer. So if you remember the network layers, that we have the application, right? So from the top to the physical, the connection. So it's more like fast and efficient. Okay, it will treat each packet in isolation. Okay, here's a called a packet firewall and stateful firewall. So it will identify a packet, a connect state. It maintains a packet history in the state table. So that's like what this firewall is doing. And also we have the application layer firewall. Okay, it inspects, also filters the package on the OS side. Layers. Okay, so up to the operation application layers. Okay, so also it identifies, so if the protocol being misused. So this one is the application layer firewall, and we have the POSIX firewalls. Okay, so it will act as like the intermediate. Okay, so it also operate at the application layer. Okay, so it not requires you have a direct connection. So no direct connection are allowed. So they're more need like connect as a POSIX. So if you know the POSIX server and set up as a POSIX firewall. So here's the mainly different type of firewalls. And we have the packet filtering firewall. So this one we call access control based on the attributes of the package or the packet headers. Okay, so maybe we have the destination address, port number, options, all this. Okay, so we have called the filtering firewall. So it's the names. Okay, so it's the how we're going to use. So we does not control the access based on the content. Okay, so mainly the router or other infrastructure system will be using this firewall. So we are doing like called a filtering firewall. So it will based on the attribute of the package. Okay. And then we have the POSIX. Sometimes we say the POSIX. So this one is the intermediate like agent, or it can be the also server. So we can use a we call the POSIX server. So it acting on the behalf of the endpoint. So without allowing a direct connection between two endpoints. So each endpoint will talk to the POSIX as a middleman. So I'm thinking just like talking to other endpoint. So if I just thinking, okay, we have a POSIX server. When I think A talking to B, and then C is the POSIX. Okay, so even you're thinking you're talking to B, actually you're talking to the C, like POSIX server, and POSIX server will also forward all your content to B. Okay, so even from B side is thinking I'm talking to A, but actually talking to the posse. So the posse will decide whether to forward the message or whether to alter them. So here's the function of the posse right here. And when we know the posse, then of course it comes with the posse firewalls. Okay, so the asset control done with the posses, right? So usually based on the asset control on the content as well as the source. Okay, destination address. So you see that here slightly different for the filtering firewall. So we don't really care content, but this time we filter content. That means that if I want to see if you are sending some really sensitive or maybe some content maybe not so good, okay, then we're going to filter out not to forward. Okay, so this posse server can do the posse firewall. Okay, also it because it's an applications level, so we can call it also application level filter like this firewall. Okay, and if we want to check the virus, like checking the virus in electronic mail, so we have a posse. Also, the mail server we can check kind of as a posse server. So the incoming mail will go to the posse firewall. So once it receives the mail, so it scans it, right? So if there's no virus, so the mail will be forwarded to the destination. If it does, okay, detect the virus, and the mail will be rejected or disinfected before forwarding. So here's the way they're doing. Just think about the email. Okay, so actually for the email you're sending out, sometimes if you try to attach some virus, okay, so they will reject it. Okay, first they were sending if something they didn't. So the proxy firewall will scan it. Okay, so it's the way before they forwarding this message, they will scan it or like disinfect it. Okay, and if they want to scan the incoming email for malware, so the firewall acts as the recipient, so they will try to get the packet first, right? So make up the message and we assemble the message. Okay, so if then they scan the message for malware, if none, then I will that means the firewall say, okay, I will forward it to the destination. If some fun, okay, so maybe the mail is discarded or there are some appropriate action depends on different service provider or the mail server. So the firewall, okay, maybe they can drop it or they can like scan it and remove those. So depends on the content. Okay, so as the email that we send both at the firewall, so by the mail agent, so we call the mail agent, so they can I think be behalf of the mail agent at the destination. So it's the posse firewall, so or we call the application layer firewall. So it's the another name of it. And we have the stateful firewall. Okay, so the stateful firewall it keeps the track of the state of each connection, pretty similar to posse firewall, but it's like no posses involved. Okay, so but this can examine the content of the connection. So we can analyze each packet. Okay, so we can keep the track of the state. So once the state indicate an attack, or the connection unblocked or some other appropriate action will be taken. So here's the idea of the state 4. So is mainly showing it. Okay, and when keep moving on, so we will talk about, if you remember the models. Okay, so we have the application layer and then presentation layer, section layer, transport layer, and network layer, data link layer, and physical layer. Okay, so when we're sending peer-to-peer, so actually like we're going down. Okay, so the flow of the bit, so into bit, or like in the middle, here will be the including the network layer. Okay, so and then goes up and goes down. So we can determine by the IP address location and go down, and then we have the physical layer and goes up to data link, network, transport, section, presentation, and finally the application layer. So you can read the content, okay, the message. So here's the normal way. And for this communication, we have the different type of protocols. One is called the end-to-end protocol. This like the communication protocol involve the end system. So with one or more like intermediate system, those like intermediate hosts, they will play as a no part of others, like then just like forward them message. So if you know the telnet, right? So the telnet, so we can do it. So it's like end-to-end protocol. And the link protocol, so this is a protocol just between every directly connect system. Okay, so if we're using the IP, so the IP say, so it will guide the message from a host to the one that immediately host. So this one like using the IP address, so we know like which one to another IP, from one IP to another IP. So there will be like two distant protocol right here, and then we have the link encryption, and we can encipher them, and we can encrypt the message between the intermediate hosts. Okay, so each host can share the cryptographic key with its neighbor. So they have this another mechanism like how we share the key to neighbors. So the attacker at the intermediate host, so they will be able with the message, so that when they edit. And we know the end-to-end encryption. So for the telnet, right, one example. So with the message, they encrypt it or decrypt it, okay, at the client and the server side. Okay, so if the attacker they're on the intermediate host, then they can read the message. Okay, so here slightly the differences between these two parts. So we have the protocol, and then for the protocol we have two different encryption. So for link encryption, so if they are in the at the intermediate host, so they can read it. But for end-to-end, the attacker cannot read the message, even they are intermediate. So here's the differences. And we try to secure at the call it transport layers, okay, for the secure socket layer. So we are using the SSL. So this one developed by the Netscape, so provide the security in the browser and server. So you remember in the previous lecture, we talked about one equation, the digital shard, right? So we sometimes TLS SSL. Okay, so security socket layer. Okay, so the SSL will be the basis of the Internet Standard Protocol. So it's a work on the transport layer security. So it's the TLS. We also say the TLS protocol. So you see always come together like TLS, SSL. Okay. And what's the key idea? So it's mainly for the connection and sections. So when we create the SSL session, so it will be actually it's the association between the two peer, right? And then the connection also is a set of a mechanism using a transport data in an SSL section. So this is the idea for SSL. Okay, and those like the parties that keep the session information. So right here they have the session identifier, and then they're using the PLX 503 certificate. If you remember, we told also we have the X 509. Okay, so also we have different. Also they have a compression method, so they can use to reduce the volume of the data. They can cipher the specification. So those are the parameter of the cipher, and then the MAC address of this. And for the master secret, we contain the 48-bit. Okay, and for the connection information, so they will contain all those like random data for the server side and then the client side. And they will save like the key, so no matter server and client, right, both for encryption, also the MAC key. Okay, so if they require, then they will have some initialization, okay, initialization like vectors for the cipher, and they will also keep track of the sequence number. Okay, so all this was being saved. So they will kind of like provide a self-support cryptography mechanism. So they said during negotiation. So maybe we have some handshake protocol, so they can provide it. Okay. And so far, if you look at this the architecture, so this is how it looks like. We have maybe have the handshake protocol, and then for SSL, they will change the cyberspace protocol and then other protocol, and then we also have HTTP. Okay, so when we have the SSL record protocol, and on top we have the TCP/IP. So you know the TCP/IP. So this one just provide a really basics for the secure communication. So we call the confidentiality and the message authority. So right here, so would be idea using the SSL. When we talk about the handshake protocol like here, so it will be the most complex part of the SSL. So it can allow the server and client to authenticate each other as well, and if you remember the RSA, so it's an interchange the crypto system. So we did cover a little bit. So quickly, so they will try to negotiate the encryption. Okay, so maybe even algorithm or the cryptographic keys or these. So it takes like 4 rounds to do that. So they will need like use it before any application data they are transmitting. So that's why we call it handshake protocol. If you learn networking, then we have more details about it. And so because they say they before they start to communicate certain data, they need to compromise it. Okay, say okay, which protocol we are using this one, how are we going to talk? So we need to do the handshake, right? Handshake, and then before we start to talk. So here's the idea. And we do have other protocol involved, including the SSL change cipher spec protocol. So it's just a single byte. Okay, so it's exchange. So after a new cipher parameter has been negotiated, then or we negotiate, then they will have a new single byte. Okay, and also they have an alert protocol, if you remember in the architecture. So they will signal an unusual condition. Okay, maybe kosher alert. So they are not sending anymore, or sometimes the error alert. So the Fractal's error, so maybe results in a disconnect. So all this will support by the alert protocol. And right here, so we see for the IPsec. So IPsec is another, if you know the VPN, so we are using it for like one of the encryption for VPN too. So with our VPN. So this one is working on the network layer. Okay, so just need to know. So it's the security at the network layer. You can use the IPsec. So for IPsec, it's the protocol, or like you can call it, the mechanism. So it's how it works. You try to encrypt and authenticate all traffic at the IP level. So it's the network. So it protects all message sent along a path, and those intermediate host, okay, with the IPsec mechanism. So including the firewalls and gateways. So we call them as a security gateway. Okay, so we can use it on the like LAN, WAN, private network. Okay, of course, like we say that VPN. So they are all possible can use it, and those are application they are independent. Okay, so they're kind of like transparent to user. So no matter the web browser, internet, FTP, so for the files. Okay, so all this what they provide at the IP level. So if you remember right here, like the network layer IP level, so we'll be providing the like access control, connection as integrity, data origin, authentication. Also, they can rejection of like replay package, and also packet, and also their data confidentiality, and then also they will limit the traffic analysis confidentiality like this. So here's a IPsec. Okay, I'm doing. So just look at here's a case where the IPsec can be used if we have the two devices and then we communicate through the internet or something like the intranet. Okay, talk about that. So it's an end-to-end security between two hosts, right? So and we set up the gate security gateways. Okay, right here. So we have through the gateway and then communicate. And if you remember the security gateway, we call them maybe the firewall gateway. So host with the IPsec mechanism. So we can call it the SG right here. Okay, and also we are mis-setting, so it will be like security between two hosts and with two gateways. So just like treat it as like this like direct connection, so through the internet. So doing the dial-up, so we can you can see right here. Okay, so if we have dial-up, maybe go through internet security gateway and go to there, and then maybe through the intranet, yes, we can access it, or some we have the end-to-end security between the two hosts doing dial-up. So we have two lines. So here the differences, like we can use like a two sides with the security gateway, and then just like one on one side. And for the IPsec protocol, okay, so we have the authentication header AH protocol. This protocol including the message integrity, origin authentication, and sometimes anti-replace service. So this is contained it, and then we can encapsulating those security payload. So we call the ESP protocol. So of course confidentiality is important. Okay, so also we try to make sure the message integrity, origin authentication. Also, we also have an anti-replace service. So you see the protocol right here. It do add more, but maybe we for the encapsulating the security payload, we will add more like confidentiality right here. And then we have the internet key exchange, if you see like IKE. So it doing what it's doing so is try to like exchanging keys like between entities. So need to communicate over the internet. So maybe they will talk about like for exchange, they will talk about what kind of authentication method going to be used, how long they to use this key, so they can define all this. Then they will start to communicate. Okay, so between those that hosts. Okay, so once they know the internet exchange key exchange. And for the IPsec modes, we have mainly two modes. One is they call the transport mode. Okay, so transport mode is therefore encapsulate the IP package data area. Okay, so the IP header is not protected. Okay, so the protection only provided by some like upper layer. Okay, so usually we use it in the host-to-host communication. So we use for the transport mode, and we have the tunnel mode. Okay, so we try to encapsulate the entire IP package in the in an IPsec envelope. Okay, so this one can help get some like traffic analysis. Okay, so that means that if we're using transmode because it only for the host to host communication. So if I try to do traffic analysis, it's still possible. And also the original IP package is the untouched in the internet. So this one is the tunnel mode. So for the tunnel, just like if we assume A and B device, and then we have the tunnel, so goes to directly. So the original package is untouched. Okay, doing when we're sending in the internet. And if you remember the replace, right? So the replace how can we using like 32-bit sequence number so to help to detect the replay of the IP package. So the sender in the beginning try to initialize a sequence number for every essay. Okay, so then each like succeeding IP package. So within like essay increments the sequence number, so they increase. So once the receiver implements a window size of W to like keep track of the authenticated package. Okay, so once they check the man and to see if their package is authentic. Okay, so or like they get the same because like when they try to replay, that means they have the same sequence number. So they say, okay, why this packet is sending again one more time? So they can like pay attention to those like replay package. Okay. The perimeters of defense over here, there are some organization system that will contain consist of some like networks or many host machine later all this, and the system, so they are like secure as the weakest link. So right here, so we need to like perimeters and defense. So its idea is just define the border and use the gatekeeper. Somewhere we have named gatekeeper. So also the firewall can act like this. So if the host machine they're like scheduled and then need to use the public network, then we will use the encryption. So that's why I say the VPN. Okay, so it's virtual private networks. So here's the idea we're going to use. Okay, so how do you think like if we're doing this like defense, do you think it's like adequate? So it try to locating and it trying like locating and securing all the perimeters and points. So it's really quite difficult. Okay, so I think so. How can we do like less effective for large and or if we are changing the border? Okay, so when you think about it, and also when we try to inspecting or ensuring that that remote connection they are adequately like protected. So also it's also difficult. Okay. Also the inside the attack, so maybe more like damaging. So how can we like provide? So that's we need to think about this, like to think is like enough to provide adequate protection and kind of like extend it. So the total isolation of the network system. So they kind of disable. Okay, so we try to use firewalls to achieve like selective border control. So maybe the configuration of the machines and softwares, and then we can limit the network access, or like maybe something comes for free. Okay, inside many devices like no, including the routers, modem. Okay, some wireless base station, all these they do have a firewall. Okay, Also, we have the alternate, if we have a firewall, so it's a host and then the immediate some access to a network. So those like immediate, they can allow or disallow certain type of access based on the configure the security policy. So it's still okay. We can do it in this way. Okay, and when I say, so what are the those like firewall cannot do? So what can't. So okay, so they are like not a silver bullet. Okay, so they only act to defense in depth, but it's not for like manage the properly. So okay, it may provide some like false sense of the security. Just really be careful. Also, it cannot prevent the insider attack. So if we have some insider and then connect in this network, so there's no way. Okay, and also just like firewall at really particular layer. Okay, or some layers we can apply it. So it's not really like enough and really powerful to like protect everything. Then we if you remember we talked about the VPN, right? So what's the VPN? So it's the private network, so configured within the in the public network. So it will appear like as a private national or international network to the customer. You know, like if you there's so many apps. Okay, if you want to subscribe, like some of people use the VPN to get the like another country's IP address, but more than that, actually it can secure. So the customer like sharing their trunks to other physical infrastructures with other customers so like this. Then we think about, okay, if we're doing, so how about the security? Okay. So this network supports a closed community of authorized users. Okay, so those users can allow to access like various like network related to the resources and service, and also it's the traffic isolation. So all their content they are secure. Okay, so including the services and resources, they are all secure. Even you're using a public internet, so just like part of a virtual private network. So like this, okay, and it can provide the security, including the confidentiality and also the integrity of data. And also the user can have authentication. Okay, so also we can use the network access control. If you remember the IP set, so we can use the IP set to be like one of the mechanisms I use to use it in the VPN, as we say. And this way we can try to secure the IP VPN, so we can use the public internet. So like this way I say, so it's the same idea. So we can provide security of the confidentiality, integrity, user authentication, network access control, and IP set. So can use it in the IP VPNs. So while we like this, and also we can use the VPN as the tunneling. Okay, so if you remember, we also have a tunneling, right? Okay, so we have two different modes. So one with tunneling, so we can acting like this. So just like imagine right here is like there's an internet, different lots of internet. So if we set up the VPN, so we have A and B. So we just like thinking, okay, I go through it, it's a tunnel, go to B directly. Okay, so now I can access it. And here's the showing you the like the typical way of the corporate network. Okay, so including the firewall. So we have the intranet. If you like inside it will be called the intranet. So including file server, web server, mail server, all this. Sometimes we have the DNS, and also some like user machine. That means the devices. Okay, so all these I put that under the firewall, and then when we go out, so we have the DMZ, the administration. Okay, and also it can handle the mail forwarding, web server, DNS. And for others stuff right here, we have another firewall. So actually when we sending, we have different intermediate, right? So they maybe have different firewalls like already implemented right here. And we have some terms like we will see. So well, including the internet, like organized connect internet inside. Okay, so and we have the DMZ. Okay, DMZ right here. We have the military zone. Okay, so right here also we have the setting the boundary by the firewall. So we can set the filter firewall as we say. So we can based on the package header, or we can have some audit mechanism. So like auditing those like packages. Okay, and then we have the proxy firewall. Have the proxy firewall, so it can give some external view and like hides the intranet. So it's also one way, and also the content of the packages and then the package and then the message. So besides the attributes of the packet headers, so all these. And here's some issue because the internet, so they are hidden from the outside world. So maybe the internal address okay can be viewed. So that means the IP they can be viewed. So the proxy will map the view address and the firewall, and also we can get the fake private address. So the NAT network address translation protocol will match those internal address to the internet address. So the inner firewall. So this is the way they're going to do. Okay, so for the IP, and also it's all handle the mail forwarding. It will hide the internal address and those incoming mail to the view server. Okay, so maybe they can add some additional income or outgoing check. So all these. And for the firewall configuration, so including the external firewall, so they were saying what the traffics are allowed, maybe some external source we can set a restriction on the IP, okay, some range, something like this, or what the type of traffic, so are we open certain port? So are we allow SMTP, HTTP, HTTPS, FTP, so all these port, okay, for these different service. Those proxy between the DMZ server, okay, so and the internet. Also, we have the internal firewall, so also we can restrict all those traffic, also from which IP to another IP. So maybe some the end user allowed to sending to other to some devices, but some devices not allowed to sending package. So we have different way to set the internal firewall, and also we can set up the proxy between the internet and outside too. So it's also possible. And here's the configuration that we can apply on the server side. And we talk about DMZ, right? So DMZ administration, so including, so it's a direct console. Actually, do they require to access? Actually, it's a really harassing, but it requires some special access. Okay, so maybe we can use the SSH connection, so allow from the internal to the DMZ administration connection. Okay, and also it only for from some specific internal IP address. That means we maybe present some we know the administrator IP, okay, or some end devices would able to control it. So this increase the security. So only through the internal firewall. So through the internal firewall, then we can access the DMZ. Okay, so to the administration connection. So far we some of the key points. So for both amount of information, direction of the flow. Okay, so they can be explicit or implicit. Okay, and for analyze, so we assume latest of model. Okay, so latest can be embed, right? And also we have the for checking, so there are compiler based check the flow at the compiler time and execution based check flow at the runtime. So we have two. And always we based on the when we check the CI, or both will be the computationality and integrity. So this we try to analyze. So you see we talk about IPsec firewall. So all this we always look at different mode or protocol. So we look at the computationality and integrity. And so far quickly we go through the our flow and also the firewall. And then for the next chapter, we will move on to network segmentation. And this one I'll keep it for next week. And thank you so much.